Good morning. Thank you for coming today. I'm Keith Hospodarsky, Senior Manager of Global XEV Platforms for Midtronics, and today I'm going to be talking to you about battery service of electrified vehicles. You may be thinking, why should I listen? Well, Midtronics has a long history of servicing batteries and testing batteries. When the market started to shift over to electric vehicles, we took note and we started working with our OEs to develop service solutions around the high voltage pack for those vehicles. So for over a decade now, we've had equipment that is out in OE dealerships and shops to service that high voltage pack. Many of our platforms are now on their second and third generation as we've developed and improved upon those solutions as well. When you look at Midtronics, throughout our history, we've had a sole focus on advancing battery management. We had expertise in the 12-volt side, and we took that and applied that expertise to electric vehicles and the new technology. So with that, we made EV one of our core product groups. And we now have a large amount of focus, a large amount of resources, engineering, and teams around these solutions as we see this market shifting towards electrification and needing to develop new solutions for the market. Speaking of that shift, one thing that we can say in really an uncertain world is that the shift is coming and it's accelerating. You've probably heard a lot of OEs talk about their plans over the next decade to make all of their new vehicles electric. Some are going to move faster than others, but in general, we see the shift over point being around the 2030 mark. At that point, forecasts are showing there'll be 60 million electric vehicles on the road, hybrid electrics, plug-in hybrid electrics, and full battery electrics. With EVs dominating new sales at that point, you'll see that to continue to progress and accelerate from that time. So these vehicles are going to be on the road and they're going to need service. I think it's important that we take a moment here and really define the types of electric vehicles. And that's important because when you start talking about the different types, it will affect what service you can do for these vehicles. Hybrid electric vehicles, of course, still have your ICE system, and you add an electric motor and a battery into the propulsion of the vehicle. Plug-in hybrids is similar as well, but you add in the capability to plug in from the wall and charge the battery from the wall. And then full battery electrics, you completely remove the ICE system and you only have a high voltage battery and electric motors within the propulsion system to move the vehicle down the road. All of these go into what services you'll be able to do, different service applications based on the technology in the vehicle. When we talk about maintenance, service of an EV is different from an internal combustion engine vehicle. With hybrids, it's additive with some additional considerations because you have high voltage components around here. But when you look at a battery electric vehicle, it takes out the entire internal combustion engine system. So you end up with fewer maintenance items. That means that there's fewer items that people are going to be coming into a shop in order to maintain. It's important to note that two of those items that you have are related to battery. You have the big high voltage traction battery that controls the propulsion of the vehicle, and then you also have a 12-volt auxiliary battery, which we'll speak about in a little bit. Can we zoom in on the graphic here? So breaking down the components of the high voltage pack can give you an idea of what you can service within it. In general, the pack is going to be made up from a base component. You have cells. Those cells will be connected into modules. They're connected in series and parallel so that you can get your desired voltage and capacity out of that module. Modules are typically seen as a serviceable component within this pack. Once you build up your modules, they'll be installed onto a cooling plate and then have coolant lines running to that so that you have active thermal management while the battery's in operation. Really, you want to be able to keep this battery in its sort of happy temperature as it goes down the road. Once you connect all of these modules in series, you'll have bus bars that are connecting these in series, getting to your desired voltage for the vehicle. And it's common to see both 400 volt architectures and 800 volt architectures in packs on the road today. And then lastly, you have a battery management system that's going to really control the pack, control when you're letting energy in and out of the pack, and then also monitor down to a cell level so that it can make sure that the pack is operating correctly, and also importantly, disable the pack if something does go wrong. Can we zoom out? It's important to note that real life doesn't look like the graphic. So this is an actual real life pack with the lid off. And you can see it's kind of a mess in there. You have harnesses going everywhere, there's coolant lines, there's a lot of high voltage orange. So it's very important to note that you're going to have a lot of knowledge, training to be able to safely and effectively work on these packs. Go ahead and zoom out. So now that we get it, that we know the components of the pack, we can get into different service strategies that you can have. These are 3 that I'm presenting. There's going to be others that are developed over time. When you look at it, one service strategy is to say, I'm not going to service these vehicles. I'm going to send them to an OE dealership. It requires no training and equipment, but it's a lost revenue opportunity, and it also could be a lost service opportunity for the future, a lost customer for the future. Then you get into replacing the entire pack. I don't want to service this pack, I'm going to replace it. That's going to require shipment of that pack. So there's an investment in training to be able to get this out of the vehicle, and then equipment to depower. This is seen as a viable option usually earlier on, where you're able to see these in lower volume. And then as you start to see volume on vehicles and more service opportunities, the third that we're looking at is actually servicing that pack, taking the lid off, servicing different components within that pack. That takes the highest level of equipment and really training, because once you take the lid off of a pack, you're exposing high voltage, the high voltage components within the pack, and you need to be able to do that safely. After you select your service strategy, you can start to look at the different applications around these. If you're going to replace the entire pack, the old pack coming out needs to be depowered for shipment. The best practice is seen below 30% state of charge for ground shipment, and it's below 30% state of charge is required for anything that's air shipment. That requires being able to connect to the pack and take the energy out when doesn't have that control that's usually done by the vehicle. For hybrid electric vehicles that crank the engine off of the high voltage pack, you can run into a situation if the battery becomes depleted that it's not able to actually turn over the engine to start. Because the only way to charge the battery is through the engine system, you get into sort of a chicken and egg situation where you're not able to start the engine to power, but you're also not able to get energy in. So you need a rescue charge, which is really like a more complicated jump start for hybrid vehicles. When you start to service within the pack, modules that we talked about earlier being a serviceable component, all of those modules need to be balanced when they go into the pack so that it can function, it has full functionality. And so you'll need to be able to balance a module before installing it. And all of these will require some level of diagnostics to determine what the issue is, and then inspection as well to ensure that the issue has been addressed correctly. Now back to that 12 volt battery that we talked about earlier. This is a good step into electric vehicles and servicing, because many people are already servicing 12 volt batteries on ICE vehicles, but the 12 volt battery in an EV is different. It might be contrary to your intuition, but even full battery electric vehicles have to have a 12 volt battery. And among other reasons, one of the most important is that you don't want your driver to worry about getting a 400 volt lethal shock when he's trying to unlock his doors. Because of the way that the 12 volt functions in EVs, it's different than the cranking 12 volt that you have in an ICE engine though. So when you're testing this and looking to determine the health of this battery, you need to keep this in mind. It's not a big outrush of current that you need to turn over an engine. It's controlling all of the systems outside of propulsion on a vehicle, and it becomes a safety system as well, because if your BMS determines there's a problem with your high voltage pack and needs to shut that down, you want the driver to have power to all of these systems, like their power steering, the self-driving, anything like that, so that they can get this to the side of the road. They don't just lose all power while they're driving down the road. What do you need to do now? The time to prepare is now, and the transition is coming fast. So what you need to do is familiar yourself with the batteries and the technology that's out there. From there, you can select a strategy that works for you. I presented 3. There's going to be others that will work best for you, and it could be a hybrid of those and a transition between those based on the make, model, year, the vehicle, and volumes, and what you determine to do with each of those vehicles. And then once you determine those strategies, you can look into what are the service applications, what's the equipment, and the training that's needed, because this is a completely new technology. There's a lot of training and certification and equipment that's needed that's outside of what you have for your traditional vehicles. One thing to keep in mind is that you're not alone in this journey. There's a lot of resources that you can find online, white papers that talk about the vehicle technologies. The QR code that's on here goes to a Midtronics resource. We have a complete EV battery service guide that goes into more detail than what I've been able to talk through in my time here, as well as other topics. And feel free to reach out to me. I have cards up here in the front and can talk to anybody after the presentation as well. Okay, well, thank you for your time.